In this video, we will learn what is the mole concept. The basic of what is the mole concept or what is a mole. A mole is a word which is used to define a quantity which is generally huge, which is, like there are abbreviations for full forms, like there are abbreviations for full forms. For instead of saying 12 bananas, we say 1 dozen bananas. So there is a mole, the word mole, to determine a quantity which we wish to express. We know that 1 dozen equals 12, and this is the most well known, the dozen. The other known are 1 gross equals to 144, 1 score equals 20, and these are the ones which are not used often in common language, in common talking or all. And there's another called the baker's dozen, which is equal to 13. Not many people know about this, not many bakers also know about this, but the baker's dozen equal to 13. So what is a mole equal to? 1 baker's dozen. 1 mole is equal to 6.022 into 10 raised to the power 23 of anything. This can be bananas or 1 dozen bananas, 1 dozen oranges, anything. 144, 1 gross is 144. If I say 1 gross bananas, it is 144 bananas. I can say 1 mole bananas. If I say 1 mole bananas, means this number of bananas. That is 6.022 into 10 raised to the power 23 bananas. 1 mole is equal to this. In the measure of number of particles, this number is called Avogadro's constant. Avogadro's constant. And denoted by the symbol Na. Avogadro's constant. So 1 mole in terms of number of particles is this. So this is just a general idea of what a mole looks like. Now we scrape a little and get to know more of what a mole is. Now let's see the exact definition of what is a mole. What is 1 mole? 1 mole is the amount of a substance that contains as many particles or entities as there are in 12 gram of the carbon 12 isotope. This is the definition of 1 mole. That means, I'll again say it in English, okay? I'm going to say again what is written here. That the number of particles present in 12 gram of carbon 12 isotope, carbon C12 isotope, is equal to 1 mole. Now, how was it? So basically this means, now we know that 1 mole is equal to this number. So this means that this statement means that 12 gram of carbon 12 isotope contains these many particles, because 1 mole is the amount of a substance that contains as many particles or entities as there are in 12 gram of carbon C12 isotope. So (12 gram) of carbon 12 contains Na, which is equal to 6.022 into 10 raised to power 23 watt. That is the point. Watt atoms. Now how do we get to this number? That this is the exact definition of a mole, and thing is, how do we get to this number is that we see how we get to this number. If we go by the definition, and you can work it out yourself too, how we get to this number is that it is known through a device called a mass spectrometer. There's something called a mass spectrometer. Through it was found that one carbon atom has mass equal to 1.99, and there are a few more digits that is irrelevant right now, into 10 raised to power minus 23. This is the mass of one carbon atom. Mass of one carbon atom equal to this. Okay, this is gram. And now the thing is, how many atoms of carbon do we need to make 12 gram of carbon C12? How many atoms of carbon do we need to make 12 grams of carbon C12? And that can only be had by dividing 12 gram of carbon C12 by 1.992, and there's a few more digits but not relevant exactly, into 10 raised to power minus 23. Now it is said that there are 12 grams of carbon in 1 mole, so 12 gram per mole of carbon C12, and this is the mass of one atom of carbon. So we write this is also gram, 1.992 into 10 raised to power minus 23 gram of, that is per carbon 12 atom. That is the way you write it, and this term comes out to be 6.022, and there are a few more digits. Let's meet 1367 into 10 raised to power 23, which is equal to the Avogadro number and Avogadro constant or Avogadro number Na. This is how we get that this is the number of particles in 1 mole. If we are talking about 1 mole molecules, that means there are 6.022 into 10 raised to power 23. This is the shortened one, the more useful one. If we say 1 mole molecules, so 1 mole molecules means these many molecules. If you say 1 mole ions, means this number, these many ions. Okay, now this we are trying to relate by the number of particles that we see. We have seen that this is what we mean when we say 1 mole. In the particle sense is this. Then we see how we get that number, how we get this number. We get it through the definition, the accepted international definition, that 1 mole is the amount of a substance that contains as many particles or entities as there are in 12 gram of the carbon-12 isotope. And in the carbon-12 isotope, there are these many particles. Here this definition is for 1 mole, and the definition is for everything. Okay, it's not for 1 mole or 2 moles, for half mole also. Now you want to know that what is the amount of a substance that will contain as many particles, that will contain the Avogadro number as there are in 12 gram. Now let's see that there is something called a half mole. There is something called a half mole. There can be something called 2 moles. So what is a half mole? If I say 1 mole of carbon, if I say 1 mole carbon-12 isotope, I mean the number of particles. Obviously, I will write Na from here on because that is too long. Na number of particles. If I say 1 mole of C12 atoms, I meant this. So it is Na atoms. This also means 12 gram of carbon-12 atoms. If I say half mole, then it means, if I say half mole carbon 12, so it means Na by 2 number of particles. It's as simple as that. And it also means 12 by 2 equals to 6 gram of carbon-12 atoms. So this is all. Half mole of carbon-12 this. If I say 1 mole oxygen, 1 mole oxygen, 16 atoms, it will mean Na of 16 O16 atoms and 16 gram of O16. I don't think we need to write the 16 here because it is like, I don't think there exists. I don't know if there exists, not in my knowledge. If I say half mole of O atoms, then it will mean Na by 2 in particles and 16 by 2 equal to 8 in gram. And the gram is what we usually mean by amount. The weight is what we usually mean by the amount. So this is the basic of mole concept. Now there's another dimension, not dimension exactly, another way of referring to a mole. We have seen moles by particles. We have seen mole by mass, that is half mole, 1 mole we have seen. Now there's another way by volume. So I'll try to get that in 1 minute. That how do we get it in volume? So 1 mole, when tried to describe in terms of volume, I'll have to rub this just a minute. Okay, so 1 mole when tried to describe, try to define by volume is, if I say 1 mole of a certain gas, let's say 1 mole of O2 gas. Now let me be very clear here. Now this O2 gas, let's see the volume angle first, then I'll clear the other thing which may be arising in your mind. I don't know, it arose in my mind right now when I was talking about this. 1 mole O2 gas in terms of volume is given by 22.4 liters. 22.4 liters will contain 32 gram will contain Na. Okay, this is not O, this is O2, and the mass of O2 is 32. So this will contain 22.4 liters. This will contain 32 grams. I am so sorry. Shit. Now the thing is, when will this be? That 1 mole of O2 gas will be 22.4 liters, will be 32 gram in weight, and will contain Na number of particles. This will happen at STP, or standard temperature and pressure. And temperature here is 273 degree, not degree, it's written as 273 Kelvin K, and pressure is 1 atm, 1 atmospheric pressure. Under these conditions, this is possible. If conditions are not such that 22.4 liters of water of O2 gas cannot be said to be of 32 grams, or cannot be said to have any number of particles. Now if I say half mole of O2 gas, it means 11.2 liters. Half mole of O2 gas means 11.2 liters. It means 32 by 2 equals to 16 gram. That means Na by 2 particles. So you see the mass, if it's an atom, the atomic mass is taken numerically into the total mass of 1 mole of that atom. If it's a molecule like O2, its molecular mass is 32. This 32 gram is taken as 1 mole of the substance. So this is basically the basic concept, or the basic behind the mole concept. I think I missed the basic why this 32 is taken as that, but let that basic be, man. I don't know if I know it. Maybe I know it. I think if I come to know it of it, I'll tell you all what I know. So this is the basic of mole concept. Hope you liked it. If you want any other concepts, please tell me in the comment section. Thank you, ladies and gentlemen.